Hello class, we are still on Ed Extension program powered by exponential computers, prepared by Aliu Law Lesson 5. So our previous class, if you could remember, we discussed on uniformly accelerated motion as we gave examples of motion and so forth and so forth. So our topic today is equilibrium of forces. When we say equilibrium, class, let's focus on what equilibrium is. This is our outline, definition of equilibrium, types of equilibrium. This is where we are focusing today. This is our topic of today. So equilibrium, the definition of equilibrium. When we say equilibrium is defined as a state of a system when neither kinetic state nor internal energy state on a system that change over a time, when there is neither kinetic energy nor internal energy. So this is what we call equilibrium. Equilibrium is a state of a system which does not change. Equilibrium is a state of a system that does not change. Anything that does not change, it's what we call equilibrium. A thing that is not moving, or if you apply something to it, it will never change. It is what we call equilibrium. Equilibrium is a system that does not change. A body that do not change a direction or is what we call equilibrium, class. This is our equilibrium. When we say equilibrium, anything that not change. So let's see this chart. This is equilibrium. They are in equilibrium, but as you can see, their weights are the same. They have the same masses. That is why the center of gravity here does not move. You see, as you can see, this is mass 1. It has the same weight with this weight of lady. The man and the lady, they have the same weight. That is why they are in equilibrium. They do not change. If weight of this man is more than weight of this, so then this thing will be falling down, and their weight are the same. That is why they are in equilibrium. They do not change and they are not moved from one place to another. Types of equilibrium. So we have 3 types of equilibrium. As you can see, we have stable equilibrium, unstable equilibrium, and neutral equilibrium. So let's take them one by one and explain. So class, when we say stable equilibrium, a body is said to be stable equilibrium if when slightly displaced or titled and released, it turns to its original position. Any object that slightly release, it will turn to its original position is what we call stable equilibrium. From the word stable, anything, when we say the thing are unstable, they are in a place where they can't move or far away from it. So if this is stable equilibrium, it tends to go back to its original position. As you can see, this is stable equilibrium. This is a ball. This is a ball. If we place it like this, it will turn back to here, the original position. Why? Because if you throw it here and there, they will bounce and come back to its original position. This is what we call stable equilibrium. Stable equilibrium, the object that will never change its direction or its position, is what we call stable equilibrium. So the condition in which stable equilibrium will be. So this is the condition. We said a body must have low center of gravity. Any body that has low center of gravity, as you can see here, this is the center of gravity. This is its center of gravity. It has low center of gravity. So you can see here, here is a high center of gravity. That is why the ball, it won't be staying here. It will come back to the place where there is low center of gravity. This is condition 1. And the condition 2, the vertical line through the center of gravity must fall within a base, even in a slight title. So this is a vertical line. This is the lines that they are in vertical. So this line, if they slightly put here, the ball, it will go like this, and it will move slowly to come back to original position. This is its original position. Even if you put a ball here, it will come back to original position, the place where there is low center of gravity. This is our condition for stable equilibrium. So then, unstable equilibrium. When we say unstable equilibrium, a body is said to be unstable equilibrium if, when slightly displaced or released, it tends to move further away from its original position. Unlike stable equilibrium, we say it tends to turn back to original position, but this, it tends to move far away from its original position. So let's see a chart. So as you can see, this is a triangle. This is unstable equilibrium. As we put this thing as unstable, you see, this is the heat. So it won't be staying here. If we put it here, it will fall like this, or it will fall like this. So it turns to change the direction. It will change the direction. The place where you put it, it will not be stay. It will change, or it will fall down, or it will change to another direction. So this is what we call unstable equilibrium. So condition for unstable equilibrium. This is the position. It has high center of gravity. When we say something is high center of gravity, so this is the place. And so it has high center of gravity. This is high center of gravity. The center of gravity is high. Why? Because they are in shape. They won't be unstable. So if we put it like this, it will turn back to here or there. So this is what we call unstable equilibrium. The condition for unstable equilibrium. Then narrow base. It is in narrow base. Any place it can be fall left or right. This is what we call unstable equilibrium. This is the condition. It has narrow. It will fall like this, or it fall like this. Is different. So this is neutral equilibrium. We are still in types of equilibrium. This is the third types of equilibrium. So neutral equilibrium. When we say neutral equilibrium, a body is said to be neutral equilibrium if, when slightly displaced or tilted, it tends to come back to rest to its new position. So you see, this is neutral equilibrium. It will totally change new position. It neither be narrow, it neither be unstable or come back to its original position. It will change new position. If you displace in a body, it will change position. This is what we call neutral equilibrium. Any object you place it will change new position. It won't be stable or unstable. It will change new positions. This is what we call neutral equilibrium. So as you can see, this is our neutral equilibrium. This is neutral equilibrium. So you see, this is new position. So this is unstable equilibrium. You see, unstable equilibrium, it will fall like this or like this. And neutral equilibrium, it will change new position. This is the position that will change. It will just slide down. This is neutral equilibrium. It will change new position. This is what we call neutral equilibrium. So thank you for listening, class. If you have any question, you can ask. You are free to ask question anywhere that you do not understand. Please ask question. We are going to ask our questions when the time is come. So you better ask your question before we ask our question. So thank you. See you next time, class.